So here we go in the multiple choice, not multiple choice, the fill in the blank section of the test. The first question, an atom has 12 protons, what's the element? Well, to find out the answer to that question, you would need to look at a periodic table. So you go over to the periodic table, you see that magnesium right here has 12 protons, right there, 12, that's the number you're looking for. Notice that's the atomic number. This is the key over here. Tells us the atomic number is always in the upper left-hand corner, and the atomic number is the number of protons. So the answer to that was Mg. How many neutrons are in carbon-14? If you look at carbon, carbon has an atomic number of 6. Please note, pay attention now, that this says 12 for the atomic mass. But remember, these numbers are the average atomic mass. This is specifically referring to carbon-14. So that is the kind of carbon that has a mass of 14. Well, since protons plus neutrons equals mass, so P plus N, I left my stylus at school, equals mass. Therefore, since I left my stylus at school, this is going to be a little sloppy. There would be 8 neutrons in carbon-14. All right, the nucleus contains the protons and the neutrons. Remember, all the mass is in the nucleus. I'm going to back up here just a second. Number 2 again. So now, did I make it clear that if I have 6 protons and some number of neutrons, forget about that, sorry about that. So 6 plus, I'm experimenting while I'm doing this, plus N equals 14, then we know that N has to be 8. Okay, the subatomic particles that are not in the nucleus would be the electrons. So I'm just going to put an E for electrons. Since the protons and neutrons are in the nucleus, what's not in the nucleus is the electrons. And so I just told you the answer to number 4, the subatomic particles that the nucleus contain would be the protons and the neutrons. The subatomic particles with a positive charge would be the protons. You have to go back to that little grid that I went through in the previous section of these test videos. And the charge on the electron cloud, electrons always had a negative charge. So if the electrons have a negative charge, the electron cloud will be negative since the electrons are in the electron cloud. Number 7, what's the charge on an atom with equal numbers of protons and neutrons? For every positive charge, you're going to have a negative charge. So they all cancel each other out. A plus and a negative makes 0. So if there are equal numbers of protons and electrons, the charge is 0. If I have extra electrons, that would mean I have extra negatives, so the charge would be negative. If I had more protons than I do electrons, then the charge will be positive. Remember though, you cannot change the number of protons in an atom. It's only the electrons or the neutrons that can change. If the electrons change, that creates charge, because electrons have a charge, and so if you add negatives, you get more negative. If you take away negatives, you get more positive. If you change neutrons, you change mass. All right, so now we're ready for number 8, the mass of the atoms in the nucleus. Which subatomic particles determine mass? That would be the protons and the neutrons. The energy levels outside the nucleus, kind of a different way to ask the same question I asked earlier, that would be the electrons. So what is that center atom of the atom called? It's the answer is in number 9. The center of the atom is called the nucleus. And the subatomic particles that are found in the nucleus, again, see number 11 is really the same question as number 8. It would be protons and neutrons. On the outside of the atom, we find the part that's involved in bonding. The electrons are on the outside of the atom, so they would be what's involved in bonding. If you remember on an earlier section of the test, we noted that neutrons are neutral. Neutral means no charge, so the part of the atom that has no charge is the neutron. So what subatomic particles give the nucleus a charge then? Well, we said protons and neutrons are in the nucleus. Neutrons, we just said, are neutral. Protons are positive, so it must be the protons that give it a charge. And the charge on a proton, again, is positive, and electrons are negative. My suggestion at this point would be to draw a picture of the atom, and maybe put a little, in the middle, put a positives and negatives, like this kind of. And label all that. Actually, I just said that wrong. Not a positive and negative, a positive and a neutron. So let's do that again. So in the middle, put a positive and a neutron. Remember, this is really supposed to be small. Then around the nucleus, you'd have these energy levels. So somehow you got to build this picture of an atom in your head. It's not a very good circle, but I'm doing this with my finger on a trackpad. All right, so you get the idea that the electrons are outside of the protons and neutrons, and this right here is the nucleus. On the outside, we've got all these electrons. And electrons are negative. Well, I'm not going to be able to draw the electrons on the outside because I clicked on something and I don't really know what I did. Anyway, the electrons are out in this area, so you're going to need to know that. And then when this atom interacts with another atom, it's these outside electrons, the outside part of the atom, that combines with, that interacts with other atoms. So the outside of the atom interacts with other atoms. So the electrons interact with other atoms. And that's going to be very important as we move forward this year.